All right, we're going to work one of the practice questions. This is the one with the graph for the kinetics module. So let me get it pulled up. All right. This is on the second practice of the kinetics module. This is a student analyzed a first order reaction and obtained the graph above. What would be the correct labels for the axes? And you've got your options down below. Once I recognize that this is a first order process, I go and I pull the equation for a first order process. And I pulled the equation that we talked about in class is the equation for a straight line. So y equals mx plus b. That means for a first order process, if I plot the natural log of the concentration at time t versus the time, the log of a on the y-axis, the time on the x-axis, I do get a straight line, but that line is negatively sloping. The slope is equal to negative k. It's not a positively sloping line, so my answer is not the log of the concentration versus time. That would give me a negatively sloping line. So I'm not going to pick that answer. At this point, it becomes a math question. It's like, well, how can I manipulate that top equation such that I would get a positively sloping line if I graphed it? Because if I just plot the log of the concentration versus time, I get a negatively sloping line. I am going to be thinking about plotting my two variables. My two variables are the concentration at time t and the time. So those do go on the axes, and if you look at the answers, the possible answers in this multiple choice scenario, all of those are involved as far as the x and the y. And the x is the time, or in this case, 1 over time would go on the x-axis. Something involving the concentration would go on the y-axis. And so basically, mathematically, I have to figure out how to get a positively sloping line out of this. Now, the first thing I'm going to do, it becomes a math question at this point. It's not a chemistry question anymore. It's a math question. And it requires an understanding of how logarithms work. So the first thing I'm going to do is I'm going to say, well, if I want a positively sloping line, let me get rid of that negative in front of k. And I can do that by multiplying through by -1. So that would get me a negative concentration is equal to a positive kt minus the natural log at time 0. So I multiplied through everything by -1. Now I do have a positively sloping line, but only if I plot the negative log of the concentration versus time. Then I'll get my positively sloping line where the slope is equal to k. The y-intercept is the negative of the log of the concentration, etc. But it requires that negative sign, and this is not one of my options. So let's think about how logarithms work. And you can try these examples. If I take the log of 2, we see that in some of our calculations for kinetics. The log of 2 to 3 significant figures is 0.693. What is the log of 1/2? If I take the log of 1/2, I get negative 0.693. That's the way logarithms work. If I take the natural log of a number, I get x, but if I take the natural log of 1 over that number, I get the negative x. And this is because the log of 1 over 2 is the log of 1 minus the log of 2. And the log of 2 minus 0.693. The log of 2 is 0.693. And what is the log of 1? The log of 1 is 0. So 0 minus 0.693 is negative 0.693. This is the way logarithms work. So if I've got the negative log of the concentration at time t, that is equal to the positive log of 1 over the concentration at time t. So the log of 1 over the concentration at time t equals kt minus the log at time 0. And that will get me a positively sloping line. I'll put time on the x-axis. I'll put the natural log of 1 over the concentration on the y-axis. My y-intercept will be negative log at time 0, but that's not important here. But that's why the answer is x on the time axis. X is equal to time on the x-axis, and on the y-axis I need the log of 1 over the concentration. That's how that question works. Again, it's a little bit tougher. It involves more math than chemistry, but it's math we should be getting familiar with.